Today we're going to solve arc lengths for odd angle fittings. We can make any degree fitting we want if we know what our inside arc length is, our center arc length, and our outside arc length. Okay, some things you need to know. We base this on information we already have, which is our radius or takeoff of these fittings. Okay, because we're starting with a 6-inch 90-degree long radius fitting. Okay, the takeoff of those fittings, remember, our nominal pipe size times 1.5. So 6-inch times 1.5 is 9 inches. That is our takeoff and is identical to our radius. Our radius is half the diameter of a circle, which means if you were to take this radius, follow it right on through, bring it around, it would create an 18-inch diameter circle. Okay. Now with that and the knowledge of the ODs of our pipe, we can figure all this out. Okay. If we wanted to move from the center line to the outside arc, we know we have to add half the OD, half the diameter, outside diameter of this pipe. If we're going from here to the inside, we have to subtract 1/2 the outside diameter to get the radius of that throat. That makes sense. Alright, so what we're going to do is we're going to start with the inside arc length. Okay. Alright, so we have our takeoff or radius of 9 inches, and we've got to subtract minus 1/2 the OD of 6-inch pipe, which is 6 5/8 is the OD of 6-inch. Half of that is 3 5/16. Okay, so we got to subtract those. Can't take 5/16 away from nothing, so I'm going to put an inch over here in fraction. Since I'm working with 16ths, I'm just going to use a whole 16th and then make this an 8. I borrowed that 1 inch from there. Alright, so 5 from 16 is 11, and we're dealing with 16ths. 3 from 8 is 5. Okay, so that is the radius of our inside arc length. That is the radius. Okay, so what that means is now we've got to multiply that 5 and 11/16 times 2 to get to diameter. Okay, because to solve this thing, we've got to know the circumference. To get circumference is diameter times pi. Well, what we have right here is radius. So radius times 2. So circumference is radius times 2 times pi. Alright, so instead of doing that longhand, I'm just going to go to the calculator. We got 5 and 11/16, right? 5-inch and 11/16 times 2 is 11 3/8. 11 3/8. Okay, that's the diameter. The diameter. Now to get circumference, we've got to multiply that now by pi. Okay, and then we'll have our circumference. Okay, go back to our calculator. We're just going to multiply times pi equals 35 3/4 of an inch. Okay. Okay, now that is that's the full circle. We don't want the full circle. Okay, all we want is 30 degrees of that circle. That's it. This is all we want. So we got to get rid of all this, okay? But before we can do that, we got to figure out how many inches per degree there are in this circle. Well, we've got 360 degrees in a circle, so we're going to divide that by 360. And that will tell us how many inches there are per degree. Okay, so now we're going to divide that circumference by 360. Okay, that gives us 1/8 of an inch per degree. 1/8. Okay, we don't want 1 degree, we want 30. So now all we got to do is multiply that by 30 times 30 equals 3 inches. That is the length of the inside arc. So if we had our fitting here, okay, and this is the face of our fitting, we would measure up from the face 3 inches. Put a mark, okay? 3 inches to our inside arc length. Alright, so now we're going to figure out the center. We want to know how long this arc length is. Well, we already know 9 inches to the center, right? So we've already got half of our problem figured out. Okay, 9 inches. We don't have to add half an OD or subtract half an OD because we're looking for the center, and that 9 inches puts us at center. So all we got to do is times that by 2, which gives us 18 inches. An 18-inch diameter for the circle we're looking for. Okay, so we're going to take that 18-inch diameter and multiply it by pi. And that'll give us the circumference of a circle with a 9-inch radius. So now we go to 18 inches times pi equals 56 9/16. All right, that is our circumference. What was that? 56 9/16. Okay. Okay, that's all the way around. Okay, that's all the way around for a circle with a 9-inch radius. Okay. Again, we don't want the whole 360 degrees. All we want is that 30. So we're going to take this circumference and we're going to divide it by 360, just like we did last time. Gives us 3/16 of an inch per degree. For every 1 degree, it's 3/16 of an inch. Okay, so we want 30 degrees. So we're going to multiply that by 30. That gives us 4 11/16 of an inch. Okay, so now if we were to go back to our fitting, okay, and measure up from the face of our fitting and put a mark 4 11/16. Okay, our first one was 3 inches. Now we got 4 11/16. We would measure both sides and put a mark. Center punch it so you don't lose it. So now we just got to figure out our outside arc length. Okay. Now, starting with what we know, the 9 inches to center, now we've got to add half the OD, which was 3 5/16. Lucky for us, this is 3rd grade math, and we get to use a calculator, so a bunch of high-speed pipe fitters like us would have no problem doing this math. Okay, now that gives us a radius of 12 5/16. Okay, so now we need to know what the diameter is. All we got to do is multiply that by 2. Again, 3rd grade math gives us 24 5/8. That is our diameter. Okay, now with our diameter, we're going to times that by pi to get our circumference. Okay, so 24 5/8 times pi. Clear this one out. 24 inch and 5/8 times pi equals 77 3/8. 77 3/8 circumference for a circle that has a radius of 24 5/8 of an inch. Or I'm sorry, circumference of a circle with a radius of 12 5/16, or diameter of 24 5/8. Okay, but again, all we need is that 30 degrees. We don't need the whole thing. That circumference is the measurement all the way around that circle, and all we need is that little piece of the pie, 30 degrees. So we're going to take our circumference and divide it by 360. And that'll tell us again how many inches per degree there are in that arc, or that circumference. So 77 3/8 divided by 360 equals 3/16 of an inch per degree. So every 3/16 of an inch you move around this circle, you're moving 1 degree. And we need 30 degrees. So we're going to multiply that by 30. It gives us 6 7/16 of an inch. Okay, so now we got our fitting. Okay, here we had 3 inches. Here we had 4 11/16. And here, what was it? We had 6 7/16. 16. So you lay these out, measure them, center punch them, wrap around, portaband blade, whatever you got to put a straight edge on there, straight line, mark them, cut it, and you'll have a 30-degree fitting at 6-inch nominal pipe size. Now I'm going to show you a quick way to do this if you don't have the time to do the math on it. Alright, let me clear this out. If you don't have the time to do the math, then you have a pipe trades calculator. Okay, easy way to do this, and double check your math if you have the time. Since we're working with 6-inch pipe, I'm going to punch in 6-inch and pipe size. Okay, the fitting we want is 30 degrees, so we're going to punch in 30, angle slope. Okay, now we're going to hit the convert button and angle slope again. That'll give us our takeoffs and arc lengths. Okay, the takeoff is 2 7/16, and I'll show you a way to double check all that. Hit it again. Got an inside arc length of 3 inches, which is exactly what we had doing it the long way. Our center arc length of 4 11/16, which is exactly what we had before. And an outside arc length of 6 7/16, which is exactly what we arrived at when we solved it, the long method. Okay, so another method for solving our takeoffs the longhand way is the tangent of half the degree. Tangent of half the degree times the radius of the fitting you're working with. Okay, radius is always the nominal pipe size times 1.5. That's what we're always going to use when we're solving takeoffs of these fittings. So again, with the 6-inch nominal pipe size, okay, our radius is going to be 9 inches. It's going to stay there. I don't care what degree fitting you're looking for. So the tangent of half the degree, what that means is if you're looking for 30 degrees, what you need is the tangent of half that degree. So we would divide that by 2. It gives us 15. The tangent of 15 degrees is, we'll pull it up on our calculator real quick. So 15 tangent, and you can look this number up in a tangent table. We're going to go with 0.268. 0.268. Okay, you can find this in a tangent table on your wraparounds, in your fitter books, framing squares. Tangent tables are everywhere. So all we're going to do is multiply that by 9 inches. Okay, and we will arrive at the same takeoff that we had before. Alright, so I'm going to take this calculator, I'm going to multiply that number right there by 9 inches. 2 7/16. Again, that's the exact same takeoff we arrived at earlier. And that's all there is to it. I hope this helps.